Hi there and welcome to our first video in our Physics 4 section in Radiation for Life. In this video we will be looking at static electricity, what happens with static electricity and the potential dangers of static electricity. Anyway, I hope you enjoy and I will see you soon. Bye bye. Okay, so let's start by having a look at our objectives for this lesson. Okay, so by the end of this lesson you should understand what causes static electricity and how the charges of static electricity will interact with each other. Okay, so how do we generate static electricity? Now, if we've got an insulating material, what we can do is we can rub it, and what will happen is that will charge by movement of electrons from the thing you're rubbing it with to the insulator. Now, if we put something next to it, okay, now compared to the insulator here, this is positively charged. Now what will happen is our electrons can move, right, let's put that behind, our electrons can move over to here. Okay, and it's that movement of electrons which causes static electricity. Now, you may have seen pictures like this where you've got this movement of electricity and you can see that one of these areas here will be negative compared to here. So we get this movement of electrons where we can see the energy being transferred in the form of light. Now, in terms of discharging, the discharging means that we get that movement of electrons from the negative area to the positive area. Probably the most common thing that you will have seen that involves static electricity is lightning. So here you get a build-up of negativeness in the clouds, and then that discharges towards the ground in the form of lightning. You can get it the other way as well, where the land becomes negatively charged and it discharges up to the cloud, but that is very, very rare. Now, this movement of electrons is generally termed as earthing. So when you discharge the electrons, when they move, it becomes earthed. Now, normally if you become electrically charged, you touch something and you get an electrostatic shock, and that's because the electrons are moving away, so you feel that energy change. Now, other things that problems that we can have with discharging static electricity is areas where it might be flammable. So places like flour mills, where the flour can be quite flammable, or a petrochemical plant where flammable gases are made. Now, if you get the static electric charge moving, then it can cause explosions, because the gases are very flammable, and that can ignite the flame of the gas. Now, attraction and repulsion. Now, we can see here that we've got two materials. One's negatively charged and one's positively charged. Now, we'll look at how we can get those positively and negatively charged in a moment, but we're going to look at what happens when we move them towards each other. Now, if we move the negative towards the positive, they will attract. Okay. Now, they say opposites attract, and you may have heard that term before, and that's the reason why they attract. Now, if we change the charge on the blue one here we can then move this towards it, and that causes them to repel. Okay, so opposites attract and like charges repel each other. Now, how do they get themselves charged? Okay, there's two ways they can become charged. Now, we can look here at a Perspex rod. Now, with a Perspex rod, you get a cloth here and a Perspex rod. Now, when you rub the Perspex rod, it becomes positively charged and the cloth becomes negatively charged. And this is because the electrons move towards the cloth. This means that we have positive ions forming here and negative ions forming here. Now, opposite to that, if we take an ebonite rod and a fur cloth, when we rub them together, the electrons move from the fur to the ebonite rod, and that means that we get negative ions forming here and positive ions forming here. Okay, so we just get that movement of electrons. So how can we reduce any risks caused by static electricity? Now, first and foremost is to make sure appliances are earthed, and we'll look at how most appliances are earthed when we look at the third lesson on electrical safety. But it's really important to make sure vehicles that contain flammable gases, liquids or powders need to be earthed before they're unloading. Obviously, when the vehicles are moving, there's obviously a lot of friction, and that can build up a lot of charge, and one spark could easily start that off. You may have experienced this yourself when you get out of a car and go to touch the door and you get that little spark. Also the same for aircraft. When they need refueling, they have to be earthed on the fuel tank, so that when they attach the nozzle, it they'll remove that charge from the aircraft through the fuel tank and down to the earth, and that means that when they start to load the fuel on, it won't ignite. Now, you can also use insulating mats, which can stop things from becoming charged in the first place. Things like anti-static sprays, liquids and cloths can reduce problems with static electricity, and that prevents the build-up of charge, and therefore there won't be any discharge. And in terms of for yourself, wearing shoes with insulating soles will mean that you're not building up that electric charge on yourself. Okay, so let's review what we've done in today's lesson. We have looked at how static electricity is formed by the movement of electrons to form negative ions, and creating a negative and positive area which the negative electrons will then move to. We've looked at how opposites attract and like charges repel, and we've also looked at how we can reduce the effects of static electricity. Anyway, I hope you've enjoyed this, and I will see you next time. Bye bye.